Hello everyone. So in today's video, we've got an integral with a little bit of that e to the x action, but also with a little bit of that rational function mixed into its blood. So at first glance, you may be tempted to do u substitution with this. You might make your denominator u, so u is equivalent to e to the x minus 1. If that's true, then du should be e to the x dx. However, we can see that this is not the same as e to the 3x multiplied by dx, because the powers aren't the same. So we can't use you can't use u substitution right out of the bat. What we can do, however, is long division. Normally, people would do long division in the same style they have it. They've got their numerator over here and the denominator. But if you would allow yourself to just humor me, I've got a little bit of method that I've come up with my own. So what you're gonna do is you're gonna take the greatest power, or the term in your numerator with the greatest power. So since there's only one term in the numerator, it's obviously going to be e to the 3x. So we're gonna write e to the 3x divided by our denominator. So e to the x decreased by 1. So what is e to the 3x divided by our first term in the denominator, which is e to the x? E to the 3x divided by e to the x is equivalent to e to the 2x, because that's really just the same thing as e to the 3x minus x. So now that we've got that covered, we're going to make sure that we remember this e to the 2x, or e to the 2x, and we're going to multiply it to the last term of our denominator, which is negative 1. So e to the 2x multiplied by negative 1, that's really just minus e to the 2x, minus e to the 2x. However, the problem here is that this is no longer equal with our original integrand, e to the 3x over e to the x minus 1. These two aren't the same anymore, because this one on the left has got a little negative e to the 2x. So how do we make sure that these two are actually the same? Well, we can cancel out our negative e to the 2x by just increasing that with e to the 2x. Because if you combine these two, well, that's just a 0, which effectively makes this and this the same. So now that we got that covered, we can actually just repeat this process over and over again until we find something that's a lot easier to work with when it comes to integration. So we got our new term here. We're going to divide that by the first term of the denominator, e to the x. So e to the 2x divided by e to the x, which is equivalent to e to the 2x minus x, which is just e to the x. So now that we've got that covered, remember what our answer was, which is e to the x. Multiply that by the first term, or the last term, which is negative 1. So e to the x multiplied by negative 1 is just minus e to the x, minus e to the x. And again, don't forget to make sure that this is just equal with e to the 3x over e to the x minus 1. These two at the moment are not, because you've got a little bit extra here. So what do we do? Again, we just cancel that out with the same term but opposite signs. Let's just write everything down, plus e to the x. Now we're going to stop here at e to the x. Why? Because 1, this is now the same thing as what we had earlier, and 2, e to the x is a lot easier to work with than our original e to the 3x. And what do I mean by that? Notice how this term that we've just written down here can also be rewritten as this: e to the 3x minus e to the 2x separated by this parentheses plus e to the 2x, which is the thing over here, minus e to the x, and then increased by our remainder here, which is e to the x, e to the x. And don't forget to finish your fraction with your denominator. And because these are all just separated by plus or minus, we can actually rewrite these as separate fractions, isn't that right? So we've got e to the 3x minus e to the 2x over e to the x minus 1 plus our second guy, which is this one. We've got e to the 2x minus e to the x all over e to the x minus 1. And then finally, our remainder. which is just e to the x all over e to the x minus 1. So we've got that down. Now the real cool thing about this is that we can actually really simplify these very well. So these two can be simplified very easily. And let me show you how. You can actually factor this by getting rid of e to the 2x. Let me show you. This difference over here is just the same thing as factoring out e to the 2x out of it. So it's going to be e to the 2x multiplied by e to the x minus 1. Because again, if you distribute this or you multiply this, you're going to be left with the same thing over here. So e to the 2x multiplied by e to the x, that's just e to the 3x. E to the 2x multiplied by negative 1, that's just negative e to the 2x, which is this over here. So divide that, you've got your ex minus 1, and then you just repeat the same thing for the rest of these. So factor out an e to the x from this. That becomes e to the x is equivalent to e to the x minus 1, and then e to the x minus 1 on the denominator. And of course, don't forget your remainder over here. So e to the x all over e to the x minus 1. Notice now that you can actually cancel these. I mean, just take a look at these two fractions over here. These guys are the same thing, which means you can cancel them. These are also the same thing, which means you can cancel them. The only thing that you can't really do anything with is this. But that's fine, because this is just a lot easier to work with than whatever we had in the original. So let's all rewrite this again. Just let me delete the whole page. And let me rewrite the question. E to the 3x all over e to the x minus 1. And remember that the things left after we cancelled were e to the 2x plus e to the x plus our remainder of e to the x all over e to the x minus 1. So these two are effectively the same, this and this. We've made sure they're the same because we've done the steps needed to do long division, or at least my version of long division. So now that we've got that covered, we can rewrite this as our integrand. So integral sign over here, and don't forget your dx. Now this is so much easier to work with, right? Because they're all separated by a plus or minus, and using a certain rule for integration, we can really just separate these into their own integrals. So we've got the integral of e to the 2x multiplied by dx increased by the integral of e to the x multiplied by dx, and then finally our last e to the x over e to the x minus 1 dx. So let's try solving this. So actually, you know what, let's just skip that part. I'm just gonna assume that you already know how to solve these because they should be pretty easy, right? Let u equals e to the 2x, which means that its du is going to become 2 multiplied by e to the 2x dx. So that's going to give us, let's just neutralize this with a 1/2. 1/2 multiplied by integral sign e to the 2x multiplied by 2 dx, which just gives us e to the 2x multiplied by 1/2, and of course its own constant. Let's just put c1. We do the same thing here, but we already know that that's really just e to the x plus its own constant, c2. So let me just rewrite this at the top. You've got 1/2 e to the 2x plus c1 plus e to the x plus c2. All that's left now is this. Now we're going to do u substitution again. If you remember from the first part of this video, we tried doing u substitution first on this, and it almost worked except the power was just different. But now it's going to work because it's going to be the same du that we solved for. So let u be e to the x minus 1, e to the x minus 1. If that's true, then our du should be the same as e to the x dx. Isn't that right? So let's rewrite this integral. So we've got integral sign u and du. We can write that because our du is literally just right here. It's just e to the x multiplied by dx, which is the same thing here. So we know that the answer is, using the rule for fractions, where the denominator is just to the power of 1 or multiplied by to the power of -1, we can use the natural logarithm. So our u is this one, right? Because the integral of 1 over u du is just natural logarithm u, of course, plus your c. So we're going to do the same thing here and also substitute for u equals e to the x minus 2 plus the natural logarithm of e to the x minus 1 and its own constant. So now we've got our answer here, but let's just rewrite it to look a lot better. So we've got 1/2 multiplied by e to the 2x plus, just ignore these c's because they're all just gonna combine into 1 later on, plus e to the x plus the natural logarithm of e to the x minus 1 plus c. And that's your answer right there. So basically, using division, we turn this into a much easier integrand to work with. We separated it after using long division into separate terms that are just separated by pluses or minuses. And using that, you were able to solve for these integrals separately and just add them on later. And now we have our final answer, which is this. Thank you.